Hello guys, welcome back to the channel. This is Rosario for Jesse, and in this video we will discuss Viem, how we can use it to send Ether to another account, so to make transfer of funds, and also how we can use it to interact with the smart contracts, so to write data to the smart contract and also to read data from the smart contract. So let's get started. Viem, it is a library that has been created for TypeScript and allows to interact with the Ethereum blockchain, either layer 1 or layer 2, and has been created by the authors of WogMe, which is a library of React hooks that also allows to interact with Ethereum, but while WogMe is designed for front-end applications because these are React hooks, Viem it is used for back-end applications, and it is a replacement to other alternative libraries like ethers.js and web3.js that are more focused on that are based on JavaScript, and this library has a focus on reliability, efficiency, and excellent developer experience. Here in the main page there are in this home page there are some comparison with other libraries like Ethers and web3.js. There are comparison for the performance. It seems that Viem it is faster. So let's create a new directory. Let's call it Viem tutorial. Okay. Let's open a new terminal and start a new node application. So npm init -y. Okay, it has created this the package .json file. Now we can also open it in Visual Studio Code. Okay, so the first thing to install would be TypeScript. We can add another, then maybe we can also close this terminal and also this one. We can start typing npm install TypeScript. Okay, then we can install Viem. Okay, let's install also node types. Okay, then we need to install also .env. Okay. Now I copied the tsconfig.json file from another repository, because this is always tricky, and then I believe that in the package.json here we have to include main, let's write type on module. Okay, Let's create a new folder src. Let's add a new file index.ts. Let's add the console log to make sure that everything is working. Hello world, perfect. Then we need to add here, this goes away. We can add the start, that should be node, tsc and node list slash index.js. That should be fine. Let's try it. Viem run start. Okay, it works. Okay, that's cool. Now another thing that we need to do is that we need to create a new file called .env, and we should add two variables: the private key of our wallet. You can retrieve it from MetaMask if you have MetaMask, and then also the RPC URL. There are many providers of RPC URL. For example, there is Infura, so you can create this API key, and this API key that allows to connect to the node that Infura provides to us so that we can interact with the blockchain, send transaction, read the data, because otherwise we would need to start our own node. So these providers like Infura provide this API key, this RPC, that it is an RPC URL that allows us to contact the blockchain without having a node. There is also another provider, that is Alchemy. There are also other providers like QuickNode, Third Party Web. There are lots of providers. You can choose the provider that you like, and then you put this link here. You can try on any testnet. It can be Sepolia, Base Sepolia, whatever you like. We will try in this video on Base Sepolia, but it is the same if you want to try another testnet. So now that we have completed the setup of our application, let's go back to the Viem documentation and let's start to create a wallet client. So a wallet client is an interface that allows us to interact with the Ethereum accounts and provides the ability to retrieve accounts, execute transactions, send messages through wallet actions. Because the first thing that we want to try is to send an amount of Ether to another contract. And so there are two types of accounts that the wallet client support: the JSON RPC account, for example, when we use in our front-end application browser extensions wallet or wallet connect, or local accounts, which is the one that we will be using, that makes use of the private key that we have stored in our M file. So the JSON RPC account, as we said, collect the information from for example, the MetaMask, the browser extension like MetaMask here. Okay, they interact with with the extension, and they make use of this client. This wallet client can be created by making use of Windows.Ethereum, but this only works on front-end application. We are in a back-end application, so we will make use of here. No. Okay, here we will make use of local accounts. So because we are directly using the private key. So there are three types of local accounts in Viem: private key account, mnemonic account, and hierarchical deterministic HD account. We will make use of the private key account. So this is the code that we need to initialize our wallet. We can copy it, go to our repository here. So let's create a main function. Okay, let's create a basic main function. We start copying this code here. Okay, no, this of course goes outside. Okay, now here the chain is base Volume. Okay. Let's format this document. Okay, this is the Great Wallet client, but we need to provide here the private key. So it says later to here we provide the private key. Okay, but we can also hoist the account, so we don't have to as you can see here, it creates first the client, then creates the account, but we need to pass the account every time we send a transaction. This way, in this other way, hosting the account, he will create first the account from the private key and then pass it to the client, so he does not have to use the account every time in each transaction. So we can use it this way. Let's copy this code. That is more interesting. Okay, private key to account. Here we have to import .env. Okay. .env. No. .env.config. Okay. Here it is always base area. We need to import okay, this one. This is process.m.private key. Okay, that should be Ace. I have always problem with the okay, here we put the backtick, should backticks 0x dollar string. Okay, now it should be fine. Okay, parse either, this must be imported. Okay, now we'll explain what it is. We are still missing some. So here we have to put the URL of the RFC URL of our provider, because as you can see here, when it creates this public client here, if no URL is provided, then the transport will fall back to a public RFC URL on the chain. It is highly recommended to provide an authenticated RFC URL to prevent rate limiting. Okay, so here there are other parameters, okay, but here we need to write process dot env dot rpc URL. Okay, now it should be find client before sending the transaction. It seems that there is this get address method to retrieve the address of the wallet. Okay, so let's write, for example, here this wallet client, so this dot get addresses. Okay. This should be a promise. Okay, so I wait. Let's put const addresses equals to, I want to take the first one. No, it should get just one address, because I provided just one key, because there is only one address for a specific private key. Console.log, let's put here something like the address is the wallet address. Okay, let's see what happens. Okay, because I provided I need to modify the private key in the env file, maybe because it needs, I have to put it without the 0. No, in reality I had to add the 0x before I forgot to put 0x before my private key in the env file. So this is the address that it has retrieved, that it is my address here, FE28. So it is working. Okay, so this is fine to create a client. So we have this wallet client. Now let's send a transaction to, for example, my second account. Let's say this one is at 0. Okay, let's send it to this one. This function converts it's an utility function that converts the ether into way. Okay, and so this returns I believe the hash of the, let's see what returns here. I believe it is the hash of the transaction, but let's see what is returning here. it returns the hash of the transaction. So here we can put the transaction hash is okay. Now we can take this transaction hash, we can go to Sequoia base scan. Okay, we can see no, it is not copied. Okay, let's go on base scan Sequoia. Okay, perfect. There was a transfer from my first account FE28 to this other account, which is 3DF, okay, of 0.001 ethers. So here we see that we have some ether. Okay, so this worked. So we have learned to send a transaction. So here we can put create the wallet client here, send transaction, send some ether to another wallet, to another address. Now let's check how we can get the balance, for example, programmatically of this address of or of my account. We can use we should use the public client. The public client is an interface, public JSON RPC API that allows to retrieve block numbers to retrieve transaction, and reading smart contracts. Okay, and you should create it this way with the create public client, all this thing here. Okay, so it basically we use it to read the function, to read something, read data from the blockchain. But since we have a wallet client, we have the possibility to extend the wallet client with the public client. So we don't have to handle multiple clients at the same time. We just use a single client. So we can do something like, I believe, let's see if this works. Okay. Now, for example, let's see how we can check the balance of contract. So it should be something like get balance. Here we have to provide the address. Let's write also Okay, this returns the balance in okay, returns the balance of an addressing way, so we have to convert the balance to Ether units using format Ether. So here we should put format Ether convert it in Ether. So let's see what happens here. Okay, the balance is 0.001. Okay. See. Okay, it's right, it's correct. Okay, now we have retrieved the balance. Now we can also, for example, interact with the smart contract. For example, let's say that we want to retrieve to deposit some Ether into a wrapped Ether contract. Wrapped Ether is an ERC20 token that wraps the Ether. So this is an example to send a transaction to a smart contract. So let's add the address of the wet contract on base volume. Okay, which is this one. And now let's see how we can call the deposit function. Okay, so to interact with the contract, we need to use a contract instance. A contract instance is a type-safe interface for performing contract-related actions with a specific API and address created by the getContract function. Okay, the API is an interface file that explains what are the function and the variables of a smart contract and how we can interact with it. This is the API, and it gets generated when you compile the smart contract, for example with the remix. So you can create a constant contract instance with the getContract function by passing an API address and a public or wallet client. Once created, you can call contract methods, fetch for events, listener for events, and so on. So I believe that we need here, there are a lot of examples. Also here there is an example to write. So here says more, let's say, using contract instance can make it easier to work with contracts. If you don't want to pass the API address, properties API, you can perform contract actions. For example, read contract, estimate contract gas. Since between the tabs below, switch between the tabs below to see the difference between standalone contract actions and the contract instance action. Okay, it is basically saying that when we use the getContract interface, so we can call, for example, the method to read data, for example, contract.read.balance of, for example, to get balance, or contract.write.mint to, for example, mint a new, this I believe it is an NFT. And we do not need, for example, to create this single function like read contract where we need to pass each time the address of the contract, the API, the function name, the arguments, and so on. Okay, this write contract, it is the same. So we create this instance one time, and we can access all the methods of our smart contracts, of our contracts. So this is cool. Let's try this. So let's write here, let's paste this code here. So this is the get contract, the address is this one. The API, we need to import the API. I will paste it in another repository. So this is the API. You can see here explains each function of this smart contract, which is the wrap editor token, and so this is the API. Cannot find the Wacom API. We should write now here import wet API from slash API web JSON wet .json, okay, with no type JSON. Okay, this should be animated. Okay, so the API should be this one for this contract. The client should be this. I don't know if we need the two clients. Public. Are there any other problem? Fix update import. Okay, let's see what happens here. Let's print out this variable. Let's see what it contains. Seems that it has imported correctly the smart contract. Now, for example, we want to call we want to call the function deposit. Contract.write.deposit. Okay. Here we put, for example, so I was calling in a not correct manner the deposit function, because the deposit function here takes no arguments in input, so here it should be called this way. we can execute this transaction here. I have also added the public client here inside the get contract because later on it will be needed when we need to read the data from the smart contract, so we can execute this transaction here. So this is the amount of money that we are depositing. Of course, the parse ether converts the amount of ether into way. So this is the transaction hash. Here is calling also this function. Maybe that we will see later. Let's comment out this. However, this is the transaction because we have here we are in block scout. This is block scout. We can search the transaction. This is our transaction. Okay, this is we are calling the deposit method. We are calling the wrapped ether smart contract, and from my account, which is this one, if we go on the state, we can see that the balance of wrapped ether of my account that before was 0.002, now it is 0.003 wet. Okay, and of course also the balance of the wrapped ether account has increased because we have deposited an amount of ether, while the balance of my account should be decreased of an amount, if you can see here, an amount that comprises not only the value that I've deposited but also the gas fee. Okay, so we can see it also here that now we have this wet contract. Now we have seen that we not only can execute the transaction, so changing the data in the blockchain with the contract distance, but we can also do it with the write contract method on the client. The only difference is that we need to provide each time the address of the smart account of the smart contract we are calling and the API. But we can also test this function, which is interesting. So we can comment out this part, and this is the code that we are going to execute. As you can see here, we are specifying the address, which is always the wet address, the API, the function, which is deposit, no arguments, and we are passing the value of the deposit, which is always the same. Yes, and we are console logging the transaction, so we can also execute this code. Okay, I have made yeah, it's a mistake here. Okay, this is the transaction hash. We can check always the transaction on Block Explorer. As you can see, always there is still we are calling the deposit method, and from my address we can check the state. Here, as you can see, the state, the balance of my of my account on the wrapped Ether token has increased from 0.3 to 0.4, and so the transaction went fine. We could also check, for example, the address of this smart contract. As you can see here, these are the two transactions that we have sent before of the same amount, and they are reported also here inside the contract, the wrapped Ether contract. Okay, so now let's get back to our code. Let's make another test. Now, until now we have called we have changed the state of the blockchain sending transactions with the deposit. Now we want to read the balance of the wallet address. This is not a transaction because we are not changing the state, but we are reading the data from the smart contract. So in this case we are calling the balance of method. Okay, so we are checking the balance of my account, which is this one. Okay, and then we are converting this result of this promise as a string because we need to create then a big int, and the big int is the input to this method format Ether, that is a utility method that converts weight into Ether, so to have a nicely formatted output. So if I run again, I should find 0.004. Okay, that is the same that we have seen here. Okay, in the last transaction. Then, as before, we can either call the balance of method from the contract instance, but we can also call it from the client, but we have to use the read contract method. So this is another example. Okay, so also here I need to convert the output of this read contract method as a string, convert it to big int, and then pass it to format Ether to convert it from away to Ether. So the read contract is very similar to the write contract. In input takes the address of the web contract, the API, the function name, and the arguments. In this case, the argument it is the address we want to check the balance for, and it is my address. So this one here. So we can also execute this code, and obviously the balance is always the same. So there are these two ways of reading, of calling, of reading the data from the smart contract, and also of writing the data to the smart contract. So guys, thank you for watching. I hope that the video it has been useful. If you have any questions or suggestions for other videos, please drop a comment below. See you in the next video.